All right, today we're talking about stats that drive decisions, and we're going to dive into the Hungry Now case. This is all about how some pretty simple statistics can tackle, really big, really real business problems. We're going to use this food delivery app as our case study to see how data can transform those super frustrating delays into solutions you can actually act on.
So, have you ever wondered why your food delivery is late? I mean, we've all been there, right? You're staring at your phone, your stomach is rumbling, and you're just thinking, what is taking so long? Well, believe it or not, the second you ask that question, you're basically asking a statistics question. And behind the scenes of an app like, let's call it Hungry Now, this isn't just a minor annoyance for them. It's a serious business problem. It was a full-blown crisis, actually. Their customer satisfaction for those late-night orders, it was just plummeting, and they had to figure out why, and figure it out fast. So what did they do? They launched an investigation.
Yep, the late-night delivery mystery. The company literally framed it as an investigation. They had to become data detectives to get to the bottom of this late-night delivery disaster.
And where does every good detective start? With the evidence, of course. For Hungry Now, their evidence file was the data. They started collecting all these key pieces of info for every single order. Things like, how long did it take, what was the customer satisfaction rating, how many drivers were actually online at the time, orders per hour, all of it. These are the clues that are going to help them crack this case.
Okay, so with all that evidence in hand, our data detective now needs the right toolkit to actually make sense of it all. And this is where a few really basic, fundamental statistical ideas come into play.
So, first things first, they just wanted to know, what does a typical delivery even look like? To figure that out, they grabbed these three classic tools. You've got the mean, that's just the average, but it can get kind of wonky if you have a few really late orders. Then there's the median, which is the value right in the middle. The great thing about the median is that it doesn't care about those crazy outliers. And finally, the mode, which just tells you the most common delivery time you see over and over.
But here's the thing, knowing the average just isn't enough. You have to ask, is that average reliable? Or are the delivery times just completely all over the map? Well, that's exactly what standard deviation tells us. Think of it this way. A high number means your performance is wildly inconsistent. A low number? It means things are nice and predictable.
And boom, this is where they find their first huge clue. Check this out. At midnight, the average delivery time is 38 minutes, which is already kind of slow, right? But the standard deviation is 12 minutes. 12. That is a massive number. It means that for every person getting their food in a pretty reasonable 26 minutes, there's someone else waiting a super frustrating 50 minutes. That wild inconsistency, that's the real problem. And this was the first giant red flag.
All right, so we're connecting the dots now. We've totally nailed down the what. Late-night deliveries are slow and they're wildly unpredictable. So the investigation has to move on to the most important question of all. Why? I mean, what is the real cause of the delay? This is the million-dollar question, isn't it? Is it the restaurants taking too long? Is it late-night traffic? Or is it something else completely? The answer has to be in the data somewhere.
So the team started comparing the late-night hours to that busy 6 to 9 p.m. dinner rush. And almost immediately, a really stark pattern just jumped out at them. Late at night, the average delivery time shoots way up, at the exact same time that the number of drivers online just drops off a cliff. Suddenly, we have a prime suspect.
Now, of course, they had to be sure this wasn't just some random coincidence. So the analysts performed what's called a t-test. It's just a statistical tool, pretty standard, that confirms whether the difference between two groups, in our case peak time versus late night, is a real thing or if it's just random chance. And the result? It was statistically significant. That's just a fancy way of saying, yep, this is a real pattern, not a fluke.
And that leads us to this number, negative 0.78. This right here is the smoking gun. It's something called a correlation coefficient. It's just a single number that tells you how strong the relationship between two things is. And what this number shows is the relationship between the number of drivers and the delivery time. Let me tell you, a score of negative 0.78, that is an incredibly strong connection.
So what that number means is that we have a strong negative correlation. The easiest way to think about it is like this. It's like two things are dancing together, but in completely opposite directions. When one goes up, the other goes down. The data made it undeniable. As the number of drivers on the road went down, delivery times went way, way up. Case closed. Okay, so we're moving from insight to action. Because look, finding the problem is great, but the real power of data is using it to actually find a solution, right? So the goal now is to turn this huge insight into a concrete plan they can actually use.
And to do that, they used a tool called linear regression. Now don't get bogged down by the name. You can basically think of it as a statistical crystal ball. It's a predictive tool that lets you answer that really powerful question. If this thing goes up, what's going to happen to that other thing?
And the model's prediction was amazing. It gave them exactly the answer they needed. It wasn't just some vague suggestion like, hey, you need more drivers. No. It was super specific and actionable. The model predicted that for every 5 additional drivers they could get logged in, the average delivery time would drop by 2.4 minutes. Now that is an insight you can actually build a business plan around.
So the action plan basically wrote itself. Step 1, the analysis revealed that critical driver shortage late at night. Step 2, the model predicted the exact positive impact of adding more drivers. And step 3, they implemented a whole new driver scheduling policy based on that data. It's a perfect, logical chain of events.
And the result? What happened after they put this new policy in place? A 15% drop in late-night customer complaints. I mean, just think about that for a second. This wasn't a guess. It wasn't some executive's gut feeling. This was a real, measurable improvement in how happy their customers were. And it was driven entirely by just asking the right questions and using some pretty straightforward stats to find the answers. So let's zoom out for a second and talk about the power of asking why. Because this whole story of Hungry Now isn't really just about food delivery, is it? It's about a whole way of thinking. It's what you could call the statistical mindset. And it's pretty simple. It all starts with a question, just being curious and asking, why is this happening? Then it uses tools to find the patterns that are hidden in the data. From there, it turns those patterns into insights, into a clear story. And the most important part, it drives meaningful real-world change. It makes things better. And really, that's the big takeaway here. What everyday problem could you solve if you started asking the right questions? Because statistics isn't just some complicated math for scientists. It's a framework for clear thinking that literally anyone can use. So the next time you're facing a really frustrating problem, whether it's at work or just in your life, take a step back and ask yourself, what data am I not seeing? What patterns might be hiding right there just beneath the surface waiting for me to find them?